Hey, what's up? It's Enigma Hood. So, a student that I'm tutoring has a very interesting question. He takes AP Calc, and on his AP Calc exam, he had this problem. And there's actually two ways of solving this, and he solved it in a very easy and unique way. And then there's a more complicated, confusing way of doing it. But the way that he did it sounds like it doesn't make any conceptual sense. So I'm going to do it both ways. I'm going to do it the way that he did it, and then I'm going to do it the alternative way, and then I'm going to resolve some of the incorrect assumptions that he was making. So here's the problem. A right circular cone is to be circumscribed about a sphere of radius equals 7. Find the height of the cone that has minimum volume. So the first thing you might want to do is you might want to draw a picture of what's going on here. They may or may not give you this picture. If they're evil, they're going to leave it out. But this is what it looks like. So when you have a cone circumscribed around a sphere, the sphere takes up like that. So some of the givens that they should give you is the volume of the sphere, 4/3 pi r cubed, and the volume of the cone, 1/3 pi r squared h. So the way that the student that I was tutoring did it is like this. He set the volumes of the sphere and the cone together, and then he just solved for h, and that's it. So you have 4/3 pi r cubed equals 1/3 pi r squared h, and then immediately you can see that the pi's cancel out, and the 3 in the denominators cancel out. And then you're left with 4 r cubed equals r squared h. And then you just plug in 7, which we have as a given, into r. And you get 49h equals 4 times 343. And then that's equal to 1,372 equals 49h. H equals 28, and that's the height. And that is correct. Now, the conundrum that my student was facing was, how does this make any sense? When you set the volumes of the sphere equal to the cone, and you get the right answer, and that is the right answer. The answer is 28. How on earth does it make any sense? Because you can see that the volume of the sphere does not equal the volume of the cone. The cone, there's all this extra volume here. So how does it make any sense? Well, let's look at the alternative way of trying to solve this problem. Well, the first thing you want to do is you want to start labeling this picture. So as you can see, this is a right angle right here. Now, we know that the radius of this sphere is equal to 7. Let's just, for the sake of argument, call that A. So that radius is A. Now, for the sake of argument, let's call the radius of the cone to be R. Let's label that R. Okay, so already we can see that there's going to be a right triangle here. So we want to label this angle as theta. Now let's call the height, of the triangle, whoops, bring that all the way down. Let's call that H. The height of the triangle is h. Now we want to label a few more components. So we know that from here to here is the radius of the sphere. So we want to call that A, because that's what we labeled as the radius of the sphere. So we know that's A, and then we also know that this height over here, this distance, is h minus a. Pretty simple so far. Okay, so what else do we know? Well, we know this. We can label this actually. Because this is over here, this is a right triangle too. It's the same triangle as this one. And so we can label the hypotenuse square root of h squared plus r squared. And that's just simply due to the formula that we know, a squared plus b squared equals c squared. If a is a side of the triangle, b is another side of the triangle, and c is the hypotenuse. So then you just solve for the hypotenuse. C equals the square root of the square of the other two sides, of the sum of the square of the other two sides. And then we see that this side is labeled r, and this is labeled h. So it's h squared plus r squared square root of. So that's what the hypotenuse is. Okay, so we have that. Now we want to create some equations to help us understand a bit more. What we can do is we can have sine theta, this theta over here, equals what? Well, what do we have over here? Well, look over here. This is a right triangle. That right there is a right triangle. And therefore, this right triangle is similar to this right triangle. So we can equate them. Sine theta equals opposite over hypotenuse. Here's the angle. Opposite the angle is A. Sine theta equals A over the hypotenuse. The hypotenuse is this, and we already have that labeled as h minus a. So we come down here, h minus a. And then when we set that equal to the other right triangle, this right triangle, because they're similar triangles. Opposite is r over the hypotenuse, which is this, which is the same thing as this. Square root of h squared plus r squared. Okay. So then we just begin to solve for r and see what we get. Let's see. So you get a root h squared plus r squared equals r times the quantity h minus a. Let's see. Then from here, you can do, okay, yeah, you gotta square both sides because you want to get rid of this square root. Yeah, so that's probably the best thing to do. So you get a squared times the quantity h squared plus r squared equals r squared times the quantity h minus a squared. So you just square both sides because you want to get rid of that radical. Okay, and then from here, looks like we have to multiply a squared on the left side into this quantity. So we have a squared h squared plus a squared r squared equals, and I think yeah, we just need to do everything out. Basically, just multiply everything out. So I should probably just do this thing here, and h minus a, and then from that, let's see, you get h squared minus, I guess that would be 2ha. 2, well, we'll call it ah. Then plus a squared multiplied by r squared. Right? And then if you simplify and multiply in the r squared, you will get, let's see, h, no, that's h squared, r squared, minus 2ah squared plus a squared r squared. Okay. And there we have it. So we can see already that we have a squared r squared on this side, and then we have a squared r squared on the left side. So those things, they're going to cancel out. And then what are we left with? A squared h squared equals h r squared times the quantity h minus 2a, if you simplify. And then you're gonna want to divide both sides and isolate that r squared. So you're gonna divide both sides by h minus 2a h minus 2a. And then we can see that on the left side, this h and this squared are going to be, that h cancels, h squared becomes just h. And then you are left with r squared equals a squared h over h minus 2a. Now you might think that, okay, we need to solve for r, so we need to square root this, but that's going to get messy. That's going to get messy. We go back, and we see that in the volume of a cone, there's r squared right there. We already know what r squared equals. A squared h over h minus 2a. So we don't need to mess around with this anymore. We can just plug in this for r squared for the volume of a cone. So we have volume of a cone equals 1/3 pi r squared h. And then that equals 1/3 pi, then we substitute this for r squared. That would be a squared h over h minus 2a. And then that's multiplied by h. And then we just simplify as much as we can. Pi a squared over 3 times the quantity h squared over h minus 2a. Okay, now from here it doesn't look like you can simplify very easily. So what you're going to want to do is you want to actually take the derivative. You want to take the derivative of v with respect to h. So dv over dh. And that can actually get you to what you want. dv over dh equals. Now this is a constant, so we're not going to derive that. Pi a squared over 3. Here we go. So this is, we're going to be using quotient rule for this. So how does that go? That goes low d high minus high d low over low squared. So it's low h minus 2a times the derivative of the high, which is h squared. So the derivative of h squared is just 2h. Minus. So that was low d high minus high d low. So high h squared times the derivative of the bottom. Now remember, we're taking the derivative of v with respect to h. So the derivative of h is just 1. It's just 1. And then what's the derivative of 2a with respect to h? But this is just a constant, so that just becomes 0. So this is just 1. All over low squared. Okay. And then that's all set to 0. Right, because we took the derivative. And then we just simplify this. So let's see. Okay, so obviously this stuff on the bottom, if you multiply both sides by the stuff on the bottom, this will cancel out here, and 0 times the stuff on the bottom is just 0. So we can just set h minus 2a h minus 2a to h minus h squared 1 equals 0. Okay. Well, let's see. The best way to go about this is to separate out some stuff. So maybe we want to write it like this. 2h minus 2a h minus h squared equals to 0. So you're gonna want to, let's see. Let me just think about this for a second. Yeah, you're gonna want to get rid of this h. This h is problematic. So we do a little side thingy. H, 2h minus 4a minus h equals 0. And then you divide both sides by h. And then that h goes away. So we're back over here. 2h minus 4a minus h equals 0. So this then leads to h minus 4a equals 0. And then you are left with h equals 4a. So now what does this mean? Well, the height of the cone remember that was what h was, that's the height of the cone, equals 4 times a, and a is the radius of the sphere. So now you have an identity here. For any sphere of radius a, whatever a might be, the height of a cone circumscribed about a sphere is going to be 4 times the radius. And in this case, a equals 7, so h equals 4 times 7, the height equals 28. So it is the right answer. But why is it that when you set the volumes equal to each other, plug in 7 for r, why do you get the same answer for h? The reason lies in the assumptions. You see, this cone that's circumscribed about a sphere has a different radius than the radius of the sphere. The radius of the sphere is a. The radius of the cone is r. They're different radiuses. So what my student was doing is he was setting the volume of this sphere equal to another cone that happens to have the same radius and the same volume. And that cone happens to have the same exact height as a cone circumscribed around a sphere. But the volumes are not the same. The volume of that cone is not equal to the volume of this cone. This cone has a very, very different volume. And you can even test that by plugging in the height. And so this is the height, and then you can plug in the height, and then you can plug in the volume of the the radius would equal, well, we have to look over here. Yeah, so we know the height and we know the radius of the sphere. So then you just solve for r, and then you can plug in at r into this formula and then solve for the volume of the cone, and then you will realize that the volume of this cone is greater than the volume of the sphere. Okay, that's it. So now you know how to solve for the height of a cone that's circumscribed around a sphere. Thanks for watching.